All right, good morning. Today we're going to get going on section 4.2. The last couple of days we've looked at polynomial functions, how to evaluate, and how to do some basic graphing. Today we're going to start with some special names or types of polynomials that we use an awful lot, and then we're going to begin looking at operations involving polynomials. So first, some names or types of polynomials that we're going to be using. We have some different prefixes that we're going to attach to our base word. So one is mono, and then the base word stays the same, so monomial. And the prefix mono means one. So when we talk about a monomial, we're talking about a polynomial that has one term. A word we've used quite a bit this year, prefix bi, and spell the rest of it correctly. Bi attached to nomial, so binomial, means that we have a polynomial with two terms. Prefix tri with the same base word. Tri, of course, means three, so we have a polynomial with specifically three terms. And then we kind of run out of gas. We don't give names to 4-term, 5-term, 6-term, 7-term polynomials. Instead, anything with more than three, we just revert back to calling them polynomials because the prefix poly means many. So this is just going to have many terms. All right, so some special names. When we say mono, that's one term. Bi is two. Tri is three. And poly just means essentially any number of terms. Okay, so those are some special names that you'll hear and see. Next, we're going to look at basic operations involving polynomials. So involving monomials and binomials and trinomials and larger polynomials. And of course, when we say basic operations, we're talking about how do we add these things together? How do we subtract them? How do we multiply them? And how do we do division of these things? So every time you've learned something new in math, going all the way back to actually before kindergarten, every time you learn a new type of number, you learn how to add, subtract, multiply, and divide. Just like we did with complex numbers a couple of weeks ago, things that have I. One of the first things we did is we looked at how to add, subtract, multiply, and divide. So we'll do the same thing with polynomials, and we'll begin with addition and subtraction kind of together because the rules essentially are the same for both of these operations. What we're really just looking to do is combine like terms. So we're just looking to combine like terms. So terms that have the same variable with the same power are called like terms. So as an example, if I asked you to add two trinomials together, x squared plus 8x minus 6, and to that I wanted you to add x squared plus 3x minus 17, to do addition of two trinomials, we're simply going to combine like terms. The habit I need you to get into, though, is whenever we're adding or subtracting, remove parentheses. Remove parentheses. Now, of course, you guys know that if there's nothing sitting in front of the parentheses, when you remove them, everything inside stays the same. When there's a plus sign in front of parentheses and you remove them, everything inside stays the same. Right? So removing the parentheses, because there's nothing in front of the first set of parentheses and there's a plus in front of the second set, everything inside stays the same. Now combining like terms, 1x squared and 1x squared would be 2x squared. 8x and 3x would be 11x. Negative 6 and negative 17 is negative 23. So the sum of these two trinomials would be 2x squared plus 11x minus 23. Okay, so pretty easy when it's addition. Like everything going back to elementary school, a little bit tougher with subtraction. So once again, let me give you two trinomials. So 3x squared, excuse me, minus 5x plus 8 minus x squared plus 12x minus 14. Right? So this time we have subtraction going on. The habit I want you to get into, though, again, is remove parentheses. So again, if there's nothing in front of a set of parentheses, when you remove them, everything inside stays the same. But if there's a minus in front of parentheses, that essentially distributes to all of the terms. So we have to essentially subtract each of the terms that follows, or distribute the negative times x squared, the negative times 12x, and the negative times negative 14. Right? So you either have to subtract each individual term, or think of it as distributive property and distribute the negative times each one. But once we've removed parentheses, we're right back to just combining like terms. So x squareds can go together. So 3 minus 1 would be 2 of those. Negative 5x and negative 12x would be negative 17x. And then the two, excuse me, the two plain old numbers, 8 and 14 is 22. So that would be the subtraction of the two trinomials. So get in the habit of removing parentheses. If there's nothing or a plus, when you remove the parentheses, everything inside stays the same. But if there's a minus in front, then you have to subtract all of the terms inside. Whether it's 3 of them, 2 of them, 7 of them, whatever, you have to subtract all. Okay? And then I'll give you another example where it's a combination of adding and subtracting. So let's go with 3 trinomials. So how about if we went 5x squared minus 1x plus 7 minus 2x squared plus 8x minus 4 plus x squared minus 2x plus 7. Okay? Again, to do addition or subtraction, here we have subtraction, here we have addition, and while I have the highlighter selected, please notice there's nothing in front of this first set of parentheses. When we have addition or subtraction going on, remove parentheses. So if there's nothing in front, everything stays the same. If there's a minus in front, that acts like distributive property. We'd have to subtract the 2x squared, subtract the 8x, subtract the negative 4, or distribute, if you will. And when there's a plus in front, nothing changes inside. Okay? And then once again, we're just going to collect the like terms. So x squareds, x squareds, x squareds. So we put all of those together. 5 minus 2 is 3, and 3 plus 1 more is 4. The x to the firsts, put all of those together. So negative 1 and negative 8 is negative 9. Negative 9 minus 2 is negative 11 of those. And then we have 3 plain old numbers. 7 plus 4 plus 7 is 18. And we've added and subtracted the trinomials together. Okay? And then one more example, if you think you need it for your notebook. And please remember, at any point, feel free to pause the video. If I'm moving too fast or you need to jot something down, of course, just feel free to pause. But I'm going to finish with a collection of binomials added and subtracted. So I'm starting you off with x to the third minus 5x squared plus 6x minus 8x squared minus negative 3 minus 7x squared plus 14x, oops, sorry, that's a terrible 4. There we go. 14x minus 3x to the third minus 16. So it's a combination of adding and subtracting. So once again, you just have to essentially recognize what's in front of all of the parentheses. So if there's nothing in front of the parentheses, when you remove them, everything inside stays the same. If there's a plus in front of the parentheses, everything inside stays the same. If there's a minus in front, again, that acts like distributive property. So we have to subtract negative 3. creating a plus 3. We have to subtract negative 7x squared, which turns it into plus 7x squared. And again, if there's a plus in front, everything inside stays the same. All right? And then we're just looking to combine the like terms. So we have an x to the third here and an x to the third here. So 1 plus 3 would be 4 of those. We have an x squared, and an x squared. So when we put all those together, negative 5 and negative 8 is negative 13. Negative 13 plus 7 is negative 6 of those. We have a 6x and a 14x. So 6 plus 14 would be 20x. And then it looks like we have 1, 2. Am I missing anything there, guys? No, I don't think so. Just 2 plain old numbers. So 3 minus 16 is negative 13. Okay? So adding and subtracting of polynomials shouldn't be too bad because it's just combining like terms. Okay? So moving on to multiplication. We're going to look at different types of multiplication. Some you're already familiar with, and then one you will not be. Here's the 3 types. When we have a monomial times any larger polynomial, so that's the first type of multiplication. And this one you guys know well, because this is just going to be distributive property. So if I were to give you as an example something like 2x times x squared plus 3x minus 4, that would be a monomial times a trinomial. How do we get that done? We distribute. We have one term multiplied by 3 terms, so we distribute. So this is one we're very familiar with. 2x times x squared, 2x to the third, 2x times 3x, 2 times 3 is 6, x times x is x squared. 2x times negative 4 would be negative 8x. So a monomial times any larger polynomial, just simply distributive property. Okay, let me give you another example just to make sure we're okay. Even if I made this one pretty darn complicated, so if we did something like 5x squared y, and we had to multiply by 3xy, and minus 2x squared y squared, could we multiply the one term on the outside by the 2 terms inside? Sure, again, it's just distributive property. So it's going to be 5 times 3, x squared times x, y times y. So 15x to the third y squared. The second, 5 times negative 2, x squared times x squared, 2 and 2 is 4. And then y times y squared, 1 plus 2 is 3. So multiplying a monomial times a polynomial, not bad. It's just simply distributive property. The second one that you're going to be familiar with is when we multiply a binomial times a binomial. And this one we've already talked about in the previous chapter. We multiply 2 binomials together using FOIL. So I'm just going to refresh everybody's memory, so make sure we'll be okay on this. So if I were to give you, I'm going to give you several examples because this one we use a lot, obviously, as you saw in the previous chapter. So if I were to give you 2 binomials multiplied together, so we'll start with something easy like x minus 7 times x plus 3. The acronym that we use to help us remember how to do this quickly and efficiently is FOIL. The F stands for firsts, so we multiply the first term in each of the binomials, so x times x is x squared. The O stands for outsides, so the terms furthest away from each other, so x times 3 is 3x. The I stands for insides, the 2 closest together, so negative 7 times x is negative 7x. And the L stands for lasts. Negative 7 times positive 3 is negative 21. About 95% of the time, the O and the I part of FOIL can be combined, like they can here, because they are like terms. So positive 3 minus 4 would be negative 4 x. So about 95% of the time when we multiply two binomials together, we get a trinomial as a result. Let me bop through a couple more, again, just for a little bit of extra practice. So 2x plus 5 times 3x minus 7. Again, binomial times binomial, so FOIL, firsts, 2 times 3, x times x. Outsides, 2x times negative 7, so 2 times negative 7 is negative 14 with an x attached. Insides, 5 times 3x, so 5 times 3 is 15 with an x attached. And lasts, 5 times times negative 7. 5 times negative 7 is negative 35. The O and the I can be combined, and so we get x squared plus 1x minus 35. All right. Again, another example. Here's finally one where the O and the I will not combine. So x squared plus 4 times x minus 3. Right? Again, FOIL, because we have two things times two things. So again, firsts, x squared times x, 2 and 1 is 3. Outsides, x squared times negative 3. Insides, 4 times x. And lasts, 4 times negative 3. And please notice the O and the I are not like terms. So first time, trinomial. Second time, trinomial. But this time, the O and the I do not combine. So we're left with a 4-term polynomial. Okay, and one last example of a FOIL. And it's just a reminder that sometimes we have special binomials that we multiply together, like 2x plus 3 and 2x minus 3. When the binomials look the same, except one has a plus in the middle, one has a minus in the middle, we give a special name to these. These kind of binomials are called conjugates. And the nice thing about conjugates is, even though it looks like a FOIL, the O and the I always cancel out. But the nice thing is, even if you don't remember that, or you don't see it, you don't recognize it, it's no big deal. When we multiply the firsts, 2 times 2, x times x. The outsides, 2x times negative 3. The insides, 3 times 2x. And the last, 3 times negative 3. Oh, then you'd say, oh, well, I have a negative 6x and a positive 6x. Those add up to 0. And so we'd get 4x squared minus 9. All right, so that's the third type of multiplication that we have going on. Did I say third? Let's see, maybe I said that wrong, sorry. That's the second type of multiplication that we have going on, is binomial times binomial. Okay, and then finally, the third and last type is essentially when we have any type of larger polynomial multiplied by any other type of larger polynomial. So this can be things like a binomial times a trinomial, or a trinomial times a trinomial, or something with 4 terms multiplied by something with 7 terms. All right, it can be any other kind of larger multiplication. Okay, so I'm going to start with ones that aren't too terrible, and then we'll kind of work ourselves up. So what if I were to give you as an example a trinomial, so x squared plus 6x minus 8, and we were to multiply that by a binomial, like, I don't know, x minus 3. So this, as you can tell, it would be a trinomial times a binomial. Right? Now we no longer have an acronym, a FOIL, a shortcut that helps us with this kind of multiplication. So we have to think in terms of instead of a shortcut, we have to think in terms of how do I get this darn thing done? And I'm going to give you two options. I'm going to first give you, right, for larger polynomials times larger polynomials, the first option is to use a version of the distributive property. And let me show you how that works. To use the distributive property on a problem like this, what I could do is I could pick up the x from the binomial and distribute it to all three terms in the trinomial. So watch what happens if I pick up just the x, not the -3, but just the x, and distribute x times x squared, x times 6x, x times -8. I could distribute the x to all three of the terms in the trinomial. Now that I've done that, I'm done with the x, and now I could do exactly the same thing with the -3. I could pick up the -3 and distribute, my screen would stop jumping around. We could distribute the -3 to all of the terms. So I can multiply -3 times x squared, -3 times 6x, -3 times -8. So I have one group of 3 that I got from distributing the x, another group of 3 that I got from distributing the -3. And then what you'd have to do is combine like terms. So we have a 6x squared and a -3x squared, combine. We have let me choose a highlighter color here. We have a -8x and a -18x, so that would be -26x. And then we have, excuse me, we have one plain old number on the end of that son of a gun. We'd have a 24. Okay, so to multiply any larger polynomials together, so 3 things times 2 things, 3 things times 3 things, or any larger, we could use this adapted distributive idea, okay, to get to our product, to get to our multiplication. Okay, and that works perfectly fine. That works perfectly great. There is a second way to do it, though, and we could multiply by what's called a vertical method. All right, so I could multiply vertically, and this is similar to the idea that you used in elementary school. If you were asked to multiply something like 234 by 26, it's the same kind of idea. If you had to multiply 234 times 26 in elementary school, I believe what you would have done is written down the 234, slid the 26 underneath, and drawn a line. And once you draw the line, then what we do is we start by multiplying everything through by the 6. So we'd multiply 6 times 4. 6 times 4 is 24, carry a 2. Then 6 times 3 is 18 plus the 2. And then 6 times 2 plus the 2 is 14. So we get 1,404. Then when we move over to start multiplying by the 2, what we're taught to do in elementary school is add a 0, because really we're not multiplying by 2, we're really multiplying by 20. And now start multiplying 2 times 4, 2 times 3, 2 times 2. And then at the end we draw one more line and add the results. So 4 and 0, 0 and 8, 4 and 6, carry a 1, and 1 plus 1 plus 4, so we get 6,084. And we can do the same sort of thing with polynomials. So if I were to now give you another problem of a trinomial, so if I gave you x squared plus 4x plus 5 and asked you to multiply that by x minus 9, right? I just showed you how to do this with distributive property, but now we could do the same thing with this vertical idea. We could write down the larger polynomial, slide the smaller one underneath, and draw a line, just like we would have in elementary school. And just like in elementary school, what we would start with is start by multiplying everything through by -9. So -9 times 5, -9 times 4x, -9 times x squared. So we start with the -9 and multiply all 3 other terms by -9. Then we add a 0, and then we start multiplying everything through by x. X times 5, x times 4x, x times x squared. We draw a line across and add. The nice thing about the vertical method is all of the like terms get stacked on top of each other, so it's a little easier to combine. So negative 9 and positive 4 would be negative 5 of the x squareds. Negative 36 plus 5 is negative 31 of the x's. Negative 45 and 0 is negative 45. All right, so we have these two options. We can multiply trinomials and larger polynomials using the distributive idea, or we could multiply them vertically like we learned to do in elementary school. All right, so probably is worth giving each a try to see if you like one better than the other. Okay, so to finish off this video, I'm going to do two more problems. I'm going to multiply two trinomials together. So so trinomial here, trinomial here. The first one is going to be x squared plus 2x minus 3. And the second one is going to be x squared minus 4x plus 1. Okay? Alrighty. And I'm going to just choose one of the methods. All right, so like I said, I'm going to do two more examples. One, I'll use the distributive idea, and the other, I will use the vertical idea. Okay, on this one, I'm going to choose the distributive idea. So I'm going to start by taking the terms in one of the polynomials, and I'll start with this one. So I'm going to start with the x squared and distribute it to all three of the other terms. So ready? X squared times x squared times negative 4x, x squared times 1. So here's the first group of three, distributing x squared times each of the terms in the other polynomial. Now that I'm done with the x squared, I move over to the 2x and do the same thing. I pick up the 2x and distribute to all three terms in the other. So 2x times x squared, 2x times negative 4x, 2x times 1. So here's the next group of three. And then finally, I pick up the negative, hit the wrong button there, guys, sorry. And finally, I pick up the negative 3 and distribute to all three of the other terms. So negative 3, oh, come on, pencil. Negative 3 times x squared, negative 3 times negative 4x, negative 3 times 1. And there's my last group of three. So three groups of three means we ended up with 9 terms. And what we have to do is look around for like terms. So we have 1 with an x to the 4th. Again, I'll choose my highlighter here to help out a little bit. We have an x to the 3rd here and an x to the 3rd here. So negative 4 and positive 2. Negative 4 and positive 2 is negative 2 of those. Then I have an x squared, an x squared, and an x squared. So I can put all three of those folks together. 1 minus 8 is negative 7. Negative 7 minus 3 is negative 10 of those. And then I've got an x to the 1st and an x to the 1st. So 2 plus 12 is 14 of those. And finally, we have one plain old number on the end, minus 3. And so our multiplication then, x to the 4th minus 2x to the 3rd minus 10x squared plus 14x minus 3. Okay, so I use the distributive idea there. And the final example for this video then is going to be using the vertical method. But I'm going to give you a different type of multiplication to do. This time what I'm going to do is multiply 3 binomials together. 3 binomials together. So I'm going to multiply something like x minus 4 times x plus 2 times 2x minus 1. Right? Now, anytime we're ever asked to multiply three things together, even if you do a real easy problem in your head like, what's 4 times 3 times 2, right? You actually don't do both multiplications at the same time. What your brain does is it picks one of the multiplications to start with. As an example, your brain might pick 4 times 3. 4 times 3 is 12. Then take that answer and multiply by the 2. 12 times 2 is 24. Or, if you go the other way, you could multiply 3 times 2 together and get 6, then multiply by the 4 to get 24. Doesn't matter. So when I give you 3 things to multiply, what we do is we start with 2, and I'm going to choose to start with the first 2, and I multiply them together. But since I have a binomial times a binomial, of course that means, back to our shortcut, FOIL. So we're going to multiply the firsts, the outsides, the insides, and the lasts. Usually I can combine the O and the I, which I can in this case. So 2x minus 4x is negative 2x. But because my 2 binomials turned into a trinomial, what I have then at this point is a trinomial times a binomial. And as I said, I'm going to now use that vertical idea. So I'm going to slide the little one under the big and multiply vertically. So I'm going to start with the negative 1 and multiply by all 3 terms in the trinomial. So negative 1 times negative 8, negative 1 times negative 2x, negative 1 times x squared. Then we add a 0, and then multiply everything through by 2x. 2x times negative 8, 2x times negative 2x, 2x times x squared. And when we draw a line across and add, again, all of the like terms are stacked. So negative 1 and negative 4 is negative 5 of the x squareds. 2x minus 16x is negative 14x. 8 plus 0 is 8. And so our multiplication result then, 2x to the third minus 5x squared minus 14x plus 8. Okay, so that's the first chunk of section 2. When I come back on Monday, then we'll take care of the last piece of section 2. So with the time remaining, I want you to get started on the assignment. For sure, get going on the adding and subtracting, get going on the easy kinds of multiplication, and even into some of the tougher types is absolutely fine. And then we'll take care of the remainder of section 4.2 on Monday. Okay, so this assignment will be due on Tuesday. Okay, so have a great weekend, and we'll see you then. Bye.